May or may not go. Okay, I'm just gonna do anatomy in you guys' space, in Brayden's place, because he's not here. So yeah, blades check. Okay, we barely have time. Okay, this is gonna be about the skeletal system because that's the system I'm most familiar with. So yeah, bone. Let's just get started. Okay, bone has four key functions. The first one is pretty obvious. It's to serve as a form of protection. Like for example, like your skull is kind of hard, so your brain doesn't get squashed by like anything. And so that's one of the key functions. The other three are actually more kind of non-trivial that you might not originally think of. First is to create blood. Surprising, but yes, the bone actually does create blood. The bone also is a great source of nutrients. Like, okay, I'm already starting to talk about bone marrow, but like if you like are familiar with bone marrow in the context of cooking, then yeah, you know that it's really nutritious, and this is why. Yellow marrow does in fact store fats. Final function is to act as levers for the muscles to move. That's basically like, okay, you can have muscles. Basically muscles work like this. They can contract and they can relax, but without anything to like pull on, it's not really possible for muscles to move you. So the bones are kind of like, because the muscles pull on bone, that's how you move. Okay. Right. Five types of bones. Here they are. Kind of they're kind of the names are kind of they're kind of what's the word? Like kind of intuitive. Yeah. Long bones are long, short bones are short, flat bones are flat. Sesamoid bones look like sesame seeds. And then you have irregular bones, which are kind of the misc. Um, Flat bones, yeah, these are kind of situational. Short bones, like for example, they're found in like your wrists. Long bones are like your humerus, if you've heard of it, like forearm. This would be a long bone. Sesamoid bone, the most famous one is your patella or the kneecap. Basically, though these are located in joints just to provide some stability. Like irregular bone, they're literally just the miscellaneous, like your vertebrae that's shown here, also your pelvis. These are all irregular bones. Um, okay. What are the bones in the ear? Haha, there are no bones in the ear. That is cartilage, and we will talk about cartilage later. Oh, there might be sesamoid bones in there. Also, we are not on here yet. Yeah. Okay. So if we haven't had enough divisions of bone, now I'm going to talk about two like key types of bone. First is compact, and this is probably what you're more thinking of when you're thinking of bone, like this very dense, solid, hard material. And this is what it is. It's 80%, it forms 80% of all bone. It's very dense, it provides protection, and basically it's a group of osteons, which are basically like bone cells. We'll get into these in a bit. And then it covers the other part, which is spongy bone. Now, spongy bone is really unique because instead of being like all compact, it's more like it's more like a matrix. This matrix is called trabeculi. You just need to memorize that. It's found in the epiphysis, which we're also going to talk about later. But it's basically this part is like really hard. Think about fractures. When you're on like, for example, your like I don't know, your leg gets fractured. It's almost always a fracture in the middle of the bone, right? Not towards the ends, because the ends has this spongy bone that's actually much more harder and much harder to break than the compact bone. So yeah, kind of cool. Also red marrow in spongy bone, that's where all the blood is produced. Like for example, if you have a fracture, you definitely want to like you definitely much rather lose some of the fat you've been storing compared to lose the ability to produce blood. Ethan, you seem like you've done this event before. Um, you can help along. Okay, bone cells. Basically, there's two very basic types of bone cells. Actually, there's four, but two of them are have to do with bone reproduction. Well, first are the osteoclasts, and the second are the osteoblasts. Now, looking oh by the way, class will still end at 5:30. I'm just gonna go a bit over time. Okay. So osteoblasts sound like they're the ones that's going to be destroying the bone, while osteoclast sounds like the one that they're going to be building up the bone. But no, it's actually the opposite. The osteoclasts secrete like small amounts of acid to dissolve like some very small fractures that occur in bone just like over time. And then the osteoclasts, so can they kind of like remove these, and the osteoblasts build new, stronger bone in order to just have the bone grow in strength. So basically, throughout use of bone, you get these fractures, osteoblasts go over, repaired, new bone, really good. Who named them? That's so counterintuitive. Actually, I think these roots are Greek, where a blast is like builder. Are there diseases that involve these cells? There has to be. I think there's that like one person who like whose osteoblast went out of control and then they're like just mummified. Osteo equals bone. That is correct. Yeah. People can leave at 5:30 if they want. Yeah, I'm not going to force you guys to stay any longer. Okay, anatomy of a long bone. This I took from a textbook. I'm not going to explain everything here. Um, biggest things you need to know. I talked a bit about the epiphysis already. The diaphysis is just the long segment of the long bone. I guess that was kind of obvious. Um, the only other thing I think that's really worth mentioning, besides like yellow marrow and stuff, is the epiphyseal line, or the plate. Now, this line is actually a plate in children. And so when bones are like growing in terms of length throughout your childhood and also mine, um, this plate is expanding. And so that's kind of what helps elongate the bone. But after you become an adult, your bones are stopped growing, the plates disappear, and then it fuses into a line. And so basically that just prevents your bones from going even longer. The plate is there just for the bones to grow inside. And this all happens in the metaphysis. I don't know if I'm pronouncing these correctly. I've never actually learned how to pronounce it correctly, but I don't know. Hopefully it works. Here, a bit more of a demonstration. So like, for example, this adult versus child, like over here, you see the separation is much more apparent. There's a plate, so it's much more easy for like the bone to grow down. Whereas within the adults, the bones are already like fused and it's not going to grow even longer. The anatomy for other types of bones is, I think, not very significant. They're like more miscellaneous, and I don't think there's anything that interesting or intuitive to talk about. Okay, moving on to the osteon. Okay, the osteon is basically a unit where there's a lot of bone cells. And so basically, I think the most important part of osteon I need to talk about are these two things. First is the lamellae, which are basically just small like cavities within the osteons. That's I think these are where osteocytes, which are bone cells, these are where they live. And then there's also Haversian and Volkmann canals that kind of connect to each other, and they just bring like blood vessels and nerves to the osteons, basically helping them survive. Ossification is the process where cartilage transforms into bone. Okay. Yeah. So basically, there's two types of ossification. Um, I've, if I'm gonna be honest, I've forgotten what they are, but basically this is kind of how this is how bone like grows, I think. Or at least this is how bones at least forms initially in babies. Like they have a cartilage skeleton and then it just transforms into bone. Yeah. Uh, this is just yeah one of the ways for ossification to happen. Like you're going to originally start with cartilage, and then there's going to be some centers where ossification happens, and then like yeah. So this one here, this is definitely going to be forming from diaphysis, and then the secondary ones form at the epiphyses, and then eventually yeah, you just form into bone. The particular order for different bones to ossify. What do you mean? I'm not quite sure I understand that. Okay, at least something more that I understand. Fractures. You thought there was just one. No, there are like a ton of different types of fractures. But yeah, basically you can look here and this is just kind of talk a bit about like how the impact is formed. Um, The one that's the most damaging is spiral ones. These are formed when like the bone is twisted and it's like really, really, really hurts. So yeah, try not to get your bone fractured and try not to get a spiral fracture. Um, Otherwise, yeah, you might need to do some like identification of fractures under like X-rays or something, but I don't think those should be too hard. Okay. Fracture healing. Yeah, this is a four-step process. So whenever a bone breaks, you get this massive swelling of blood that's called a hematoma. And so basically within this hematoma, they're going to form like at least first like fibrocartilage, and then they're going to rebuild the bone, and then eventually like the hematoma will disappear, and then the bone will be reintegrated with the previous bone. And so yeah. I know I'm speeding through things. I don't have a lot of time. Yeah. There are several different ways to repair fractures. Okay, that one's new on me. You want to explain a bit more? Is the screen flashing for everybody? It's fine on my end, but oh dear. What the hell's going on? All right. I'll try resharing. If it doesn't work, then I'll just let you guys go early. Can you guys see this? Or is it so really, is it still flashing? It's good? Okay. Okay. Pressure healing. Still flashing for someone? Jeez. Now it's stuck between like okay and full screen for me. Do different fractures take a different amount of time to heal? I'd have to assume. Um, Starting to flash for everyone. All right, I give up. Yeah, sorry about this, everyone. I mean, I don't have anything else left for the rest for you guys. So if you guys want to go, I suppose you guys can go. Newly repaired bone is stronger than the old ones. That's true. I watch Kurzgesagt. Personally, I'm not a fan of those types of videos, but I don't think they're bad. I'm not reading One Piece. All right. No, there's not gonna be more content.